Structural Analysis 2, Chapter 9, Force Method in Indeterminate Structures. So this time we want to solve our previous problem like an 1-degree indeterminate frame with a far simpler approach, which is the graphical solution. So as soon as we have our problem, like finding the vertical reaction at support at 6. So all what we do is to find what is the vertical reaction at support C, which this is a fixed one, and there is a roller at C. So it's 1 degree statically indeterminate, that's 1 degree. So again, we release the support at C and again bring it back, calculate the structure and bring it back, and with the effect of superposition we add it together with either of the methods. So in the graphical solution, as soon as you release the support C, you have a real moment reaction, like then you have the real force, then all the forces from a structure, and just apply a one keep upward force in direction of RC. As soon as you have this one, if you draw the moment diagram, you can easily see these forces doesn't create any moment. This horizontal force doesn't create any moment in the horizontal part, so the moment here is 0, and this moment, this force, the 4 kips times the arm of 12, it just gives us 4 times 12 gives us a 48 kilopounds feet in terms of moment in graphical method. Plus, with the virtual condition, this force times the arm of 18, there is no moment here, there is no nothing, and it just gives us a 1 times 18 gives us 80 k feet. And with the same amount of force, and it just like a rectangle goes all the way down. So if you want to draw both moment, it just gives us a triangle here, 0 here, a triangle here, and a rectangle in the vertical component. It both in real moment, virtual moment, because we are applying the force method to calculate our structure. As soon as we have this one, we can jump to the table for calculation of a m times small m prime is capital M, and can easily see in all case for this part, for the vertical component, we do have a triangle 1 times delta 1p is integration of 0 to L small m capital M. This is a small m capital M table for evaluating, and you can easily see we do have for vertical component have a triangle times a rectangle. So that case is triangle times rectangle. It just gives us a half of small m times capital M times the length of that part, which is 12 feet. And the other component is a 0 times a rectangle. So we don't need to care about that because that's a 0 one, and that's a half of m half of small m capital M. So this is half of small m capital M. The real moment is small m is 18, a half of 18 times capital M 48, which is here, and times the length of vertical component. So that gives us this part, and as soon as you calculate that, it just gives you a 5184, and that's over EI. Because we have EI in D, we just have this part, and that's a numeric value of 5184. Then if we just move for the second part for calculation of delta 1 R, the first part remains the same, just the virtual movement of 1 keeps, and the other one, this is small m for delta 1 R. Again, this is a small m capital EI, times dx. A small m remains the same like what we have before, a triangle with the rectangle of the amount of 18. But for the real moment, it's nothing but r redundant or unknown force of c times the same amount. So we have a r times 1 kilopounds, which is gives us rc. And again, we do have 18 times r for both of this part. And delta 1 r, if you just take r out, you can easily see for the vertical component, that's a rectangle times rectangle. So rectangle times rectangle is simply small m capital M, as you can see here, small m capital M times the length of vertical component, and the horizontal part, the big part, is triangle times triangle, which is a 1/3 of small m capital M. So as soon as you have that one, you can easily see this small m, we take out r, and that's 18 times 18 times the length, which is 12 vertical component, and again 1/3 of small m, 1/3 of a small m here, capital M, which is 18 times the small m, 18 times r is out here, and times the length of horizontal member, which is 18. If you add this part, it just gives you delta 1 r is equal to 5832 over EI times the redundant reaction, which is RC. And from the superposition, we do know compatibility of deformation again tells us delta 1 p plus delta 1 r goes 0 because C cannot move vertically. In that case, 5184 over EI plus 5833 for EI times the reaction, we can get the same numeric value, 0.889 kilopounds for the reaction at C. Thank you. That was the second solution for 1 degree indeterminate structure. We'll solve more problems.